Hello, welcome back to our geography class. In our previous class, we talked about map reduction and enlargement, which also talk about direction, grid, bearing, and how to use your compass on a map in locating a location. Today, we are going to be moving forward to map work 3, which is content include method of showing relief on map, identification of landforms on topographic map, gradient, cross sections, vertical exaggeration, intervisibility. It's going to be showing you how to work with your map. Now, first and foremost, talking about the method of showing reliefs on map. This includes in detail how elevation and depression is represented on our map. And we have several ways of showing that, which includes trigonometric stations. It shows the elevation or depression of a point or a particular place using a triangle, last sign, and numbering. Also, we have a benchmark. Benchmark shows arrow and also a numbering in denoting the elevation or depression of a particular location. Spot height is in form of a contour line having a dot at the center to indicate the spot and its height. Layer tinting is also a method which includes coloring of a relief to show the height of the place. The thicker the color gets, the thicker and higher the relief is. We have archery. It also denotes a method of showing relief. Hill shading is also a method. Form lines is also a method, but majorly contour lines are mostly used in denoting relief on a map. What then is contour line? A contour line is an imaginary line that is drawn on a map to join equal places of the same height above or below the sea level. We can also say that contour lines are marked in intervals to show the regular interval between the heights of a place. For example, we have 200 meter, 300 meter. That is to say that all the places are of intervals on the map, and the difference between two contour line is called vertical interval. Like what we have here, we have 500, 400, 300, 200 meters, and we can see that the difference is 100 meter. Now, this contour line can be used to represent some various landform on our map. The first of which is a valley. A valley is a landform that occurs in between two islands or a mountain. And the contour line that represents this landform is always in V shape. The height increases from the innermost to the outermost contour line, and the outcome is always a depression. The next we have a spurs. Spurs is just like a valley, but rather it is a projection out of a valley to an island. It is usually that part that separates an island from a valley. In the contour line, the numbering decreases as it goes to the innermost contour line. The next here we have an even slope. It is widely spread to show that the of even height. The next is a steep slope. It is represented with a contour line that is very compact to each other, while a gentle slope on the other hand is widely spread from each other. This means that the closer the sequence of a contour line, the steeper the landform. The next landform representation is a convex slope. It is represented with a contour line that is closer at the lower part and increase or spread out on the higher part. And this landform produces an N shape in cross-sectional drawing. The opposite is concave slope. When representing it with a contour line, the lower part has a spread contour line while the higher part is close and compact to each other. This usually produces a U-shaped form of cross-sectional drawing. The next is escarpment. The contour line representing an escarpment on a side of the ridge is widely spread, and the other side it is compact, and it shows that the two sides are of two different landforms. Representation. Next is a knoll. A knoll is just like a conical hill on a lowland, and it is basically like an elevation on a plain or lowland. The next is a conical hill. As its name implies, it takes the form of a cone and the height increase inward. Also, a rounded top hill is just like a conical hill, but the agent of erosion has acted on the cone and it has made the center a rounded form of hill, and also the height increase inwardly on the contour line. This is a way of representing the landform of a conical hill and a rounded top hill. Why a knoll is just like a projection of a cone on a plain land. The next representation is an undulating lowland. This shows the unevenness in the rising and falling of lowland, and this is indicated by a zigzag form of contour line. A plateau is an upland that is majorly known for its broad peak and it's almost of equal height above sea level. The next is a ridge. A ridge is an elongated island and it varies in height, shape and also in form. But on a contour line, a curve separates two peaks on a ridge, while a pass is different in the sense that it goes down to almost the ground level in its separation, but a saddle is similar to a curl, but the difference is that a saddle is wider than a curl. So this explains the contour line drawing of various landforms on a map. What we have to talk about next is a gradient. A gradient talks about a change in height or the rate of change in height with the distance that is being covered. Firstly, we ought to know that contour lines shows various elevation on a map, but as these various elevations occurs over time, we need to know how the height is acquired or inclined in the sense of calculating our gradient. To calculate our gradient, the vertical interval of a contour line must be known and also the equivalent of the horizontal distance. For example, what we have from distance A to B, it's the vertical interval. To determine the gradient, the horizontal equivalent must also be known, and this is gotten by converting the distance of the same vertical interval to the actual ground distance that is covered by the two observed points. And this is done by measuring the map distance and converting it with the use of map scale to get the actual ground distance. As you can see, from distance A to B covers about 10 centimeter on the map. Given a scale of 1:50,000 centimeter, to calculate the gradient, all we need to do is to get the measurement of the map, which is 10 centimeter, then we multiply it by the scale, which is 50,000 centimeter. This will give us 5 kilometer, but we are not working with kilometer because the elevation is in meter. We have to convert from kilometer to meter, which is 5,000 meter. Having gotten our vertical interval and our horizontal equivalent, we divide to get our gradient. Our vertical interval is gotten by subtracting the highest point and the lowest point on the observed location on the map, and this will give us 500 minus 200 to give us 300 meters above sea level. To get our gradient, we divide 300 by 5,000 meter, and it gives us 1/16.7 meter. and this is interpreted that every 16.7 meters we travel or we go, we get a 1 meter increment in height, and this is what gradient talks about. For our cross-sectional drawing, this is a way to represent or interpret topographical map in a visual way, or to talk about the terrain in the way that we can see or project. There are procedures in projecting a cross-section. Firstly, you draw a straight line to join the 2 points to be drawn on the map. Secondly, you choose a vertical scale from the lowest point on the line you've drawn to the highest point on the contour number, so as to be able to represent the landform from the map to what we can actually visualize from a cross-sectional drawing. For example, if you're drawing a hill, it must be to scale so as to understand what the hill looks like. And to give full detail of the landform, it is probably better to use a graph paper to choose the best vertical scale for drawing a cross section. And as we can see here, the first step is to join the 2 points to be drawn on the map with a straight line, so as to be able to connect and get the accurate information. Second step is for you to choose a vertical scale. It is best for students to use graph paper in order to choose a better scale to draw the cross section. The next is to place a sheet of paper on the line that have been drawn, and with the point of intersection of the paper with the line, you indicate with numbering of the contour line. After this paper have been placed and indicated, you transfer the paper to the scale and you indicate, just like we have here. You get the point and you transfer the indications to the vertical scale in order to join the lines of the cross section to give us a landform that is represented using a contour line. Most of the times it is shaded to get a clearer view. Now, talking about vertical exaggeration, it is a way in which we express our cross-sectional drawing to be able to view that landform we are exaggerating. So this actually talks about how well we are able to zoom into an environment using our scale, so that we'll be able to understand the relief or the landform we're talking about. There are some steps in calculating vertical exaggeration, and this has to do with getting two important scale, which is vertical scale and horizontal scale. Here we have 1 centimeter to 100 meter. We have to convert to the same unit of measurement, which is centimeter. We have 1:10,000 centimeter, and our horizontal scale is 1:50,000 centimeter. All we need to do is to divide our horizontal scale by our vertical scale, which is 50,000 divided by 10,000, and we see that landform was exaggerated 5 times, that we'll be able to get adequate information of that landform. Now, moving to intervisibility. The intervisibility of two places is the ability for from point A to point B to be viewed, and there is no obstruction in between, and this can only be seen when there is a valley between the 2 points of observation. Most of the times, the intervisibility of 2 points can be obstructed either by vegetation or by landforms, which is mostly hill or mountain. So intervisibility talks about the ability to view another landform from a point, and the 2 points is tend to be intervisible when there is no obstruction between the two specific locations. That's all for now. Until the next class, stay calm. Thank you. Bye for now.